So good morning, everyone. Thank you for being here at the first session of the day, getting up early with us. My name is Candace Pearson, and I'll be the moderator for the panel, so you won't hear me talking too much. But we've been talking about the schedule for the event today, and it's really clear that tiny homes, this really new, cool way of thinking about this kind of disruptive technology, is bringing us all together and to talk about a lot of broader housing issues, right? So we were looking at the schedule, and there's sessions about affordability, accessibility, environmental impacts. So we're just really excited about that. This is kind of tiny homes as this launching point for talking about all of these other issues. And health impacts, our topic for this session, is one of those broader issues. There are some unique challenges with making sure tiny homes are comfortable and healthy places to live. We'll go over those today. But it's also a common problem with a lot of our building stock. So my hope is that whatever you take from this session can be applied to whatever kind of place you live in, whether it's an apartment or a house or a tiny home. So one more thing before I introduce the panelists. I want to think about what kinds of things can actually be healthy, right? Living things. So buildings can't be healthy, but people are healthy, right? So as we start off the conversation, I want to note that everyone on this panel agreed that there's not like a fail-safe checklist for creating a healthy building. What you can do is build in a way that supports healthy living practices. So that's where we'll start off today. And as we go through the session, we're going to have little cards that you can fill out to submit your questions. So if you want to jot questions down while you're doing that, Alex will be collecting those, and I'll be filtering those, and we'll go through questions at the end. So I'm going to introduce our experts here on the panel. We'll start with Anderson Page. He built his first tiny house as a student at Northeastern University. Some of you might have seen him in the documentary Living Small. And he now runs his own business, Tiny House Crafters, where his team builds tiny homes and sells design plans. Maille Baiser is a partner at Helm Construction Solutions, a construction management and consulting firm specializing in green and high-performance building. They provide pre-construction, estimating, and project management services to builders, architects, and owners. And Peter Yost is Vice President of Technical Services at Building Green, which is a publishing and consulting company. His expertise ranges from construction waste management to moisture and durability issues. And he's also a well-known teacher and trainer, so I would look out for some of his sessions if you're interested in that. He's also my boss, so I can't say very many bad things about him. So great. Yeah, so let's get started. So since this is the first session of the day, I wanted to start with you, Anderson, to set some kind of boundary conditions for us. What do we mean when we talk about tiny homes, and what are some of the challenges that are unique to them?
Yeah, all right. Thanks, Candace. Thanks, everyone, for being here. I'm Anderson Page of Tiny House Crafters. We kind of got the intro, so thanks a lot. So what is a tiny house? For our purposes, or for at least my talk, I'm going to be talking about tiny houses on trailers, which are usually 8.5 feet wide and anywhere from 18 to 26 feet long, which gives you about 150 to 200 square feet of living space. A tiny house has all the same amenities that go into a normal house, which is why we love them so much, but within a much smaller footprint. It's basically the same, but without all the excess drywall and flooring subtracted. Maybe we should stop calling them tiny houses and start calling them condensed houses. While a tiny house is not revolutionary, it is certainly unique and comes with challenges that aren't as apparent in larger houses. Today I'm going to talk about concerns when considering tiny house ownership, mainly cost and time commitment, but I'm also going to talk about some overlooked issues such as humidity, mold, and air pollution caused by combustion appliances. So cost and time commitment. First, to bust a widely held myth, tiny houses are not cheap. There's the cost of materials and compensation for labor, whether you hire a professional or do it yourself. That's not to be said a DIYer can't do it cheaply, it just might take you a while to teach yourself all the necessary skills and scrounge for recycled materials. Food for thought is that our house materials are in the range of $18,000 to $25,000. That includes the trailer. Of course, that number can go down if you use recycled materials or wait for a bargain, but it's not enough just to say, let's use all recycled materials and expect big savings. Because then you must consider the time it takes to find and store these materials, and many recycled materials are not suitable for building a structurally sound and healthy full-time home. And please take my advice, never buy a used trailer unless you are qualified enough to assess the trailer's structural integrity. Buy quality trailers from reputable sources like Jason at Granite State Trailers, who has a booth over in the parking lot. So how long does it take to build a tiny house? Well, I'm a full-time builder, with a team of 3 experts, an enclosed working space, and with all the tools. And it takes us about 800 man-hours, or 108-hour days, to complete a tiny house, and that does not include design time. Even though a DIYer might not pay for labor, making the house seem cheaper, your time is still a precious resource. Consider the cost of spending all your weekends and vacations on your project. And then I think I'm going to come back and talk about some of the mold and humidity issues after these guys talk.
Yeah, so I want to go to Mel, and you brought up some issues about cost and scheduling. So I want to go to Mel because she's the kind of construction manager of the group, and ask what kind of questions someone who's thinking about doing a tiny home might need to ask themselves when they're going into a project.
Yeah. Good morning, everyone. I'm Mel Baiser, as Candace mentioned. I'm one of the owners of Helm Construction Solutions, and we provide project management and triple bottom line business consulting to builders and architects and owners throughout New England. So tiny house, though it's cuter and potentially more complex, it's still a house, as Anderson mentioned. So when I meet with new clients who are looking to build their dream home, I always ask them about their vision, their priorities, their expectations, and their restrictions. And it's really no different with a tiny house. So with the few minutes I have this morning, I want to ask you to consider some of the goals that you have prior to embarking on this path of building your own tiny house. Because whether you pull it off for $20,000 or you sink $80,000 into a tiny home, it's still a big investment. So number 1, is your tiny house meant to be short-term or long-term housing? Is it full-time or part-time? This matters because the amount you invest in the material selection and the design details will have a huge impact on the durability of your building, on the comfort and the air quality and its performance, something Peter will get into a little later. Second, have you ever lived in a space this tiny before? How do you know you can do it? I have heard stories of people who've purchased tiny homes and have found out over time, especially in climates like ours where you can't be outside, the entire year, that the space restrictions were just too much, in particular for an individual who may have a family or a pet. So if there's any way you can test out living in a tiny space prior to building your own, might be a good idea. Third, is it important that it's mobile, or would you prefer it to be on a permanent foundation? These questions have an impact on the cost, but also on the design limitations. When it's on a trailer, obviously there are weight and height and length restrictions, and so it's just an important question to ask yourself. I think a lot of folks build tiny houses on trailers and then end up not moving them much, so it's a question. Number 4, have you done your homework to estimate the cost? And by this, I don't mean going and Googling how much does a tiny house cost, because you'll get a wide array of answers, but actually itemizing all the expenses you'll incur in the process. So part of this, in particular for the DIY tiny house crowd, is asking how much of your time you'll be investing in this process. How involved do you plan on being in the construction? Will you buy it already built from a company like Tiny House Crafters? Will you order a kit to assemble, or will you spend hundreds of hours of your time scrounging for recycled materials and cobble it together with your friends on the weekend? Obviously, understanding the time it takes to build your tiny home and whether or not you actually have that free time is really important. And keep in mind that your time has a value. So don't forget to add in all the non-building costs, the trailer, the permits and fees, the plans or the design and consultation, any site work, solar. And once you've added all that up, add another 10 to 15% for contingency. So considering it's very difficult to get a conventional bank loan for a tiny house, it's best to have all this financing in place before you start the process. It's also hard to get a tiny house insured. So given all of this, ask yourself whether or not this is a good investment. And then ask yourself whether or not you care if it's a good investment. So know your limitations. I'll speed up a little here because I'm running out of time. And know when it's important to call in an expert. Do you have the skills and the resources to do the construction yourself? Where do you hope to put your tiny house if it's on a trailer? Be sure you understand the local codes and zoning restrictions so you don't end up with a tiny house that you can't park anywhere legally. If your tiny house has indoor plumbing or is on a permanent foundation, research water and wastewater restrictions. Fortunately, there are panels on both of these topics later today. Last, consider how you want to coexist in your community. Do you mind being isolated out in the woods? Do you enjoy being part of a neighborhood or a co-housing situation? Think through the potential impacts that choosing to live in a tiny house will have on how you interact with those around you. So if you've gone through and you've asked yourself all of these questions and reflected on your goals and you still want to build a tiny house, well, you're in the right place. Today is full of resources, expert opinions, personal stories, and actual tiny houses. Thanks.
Thanks, Mel. Appreciate it. So, Peter, I want to go a little bit deeper into, we've kind of covered cost and how you might launch into your project so that it doesn't end up failing or putting too much money into it. I want to go deeper into the kind of performance and health issues that these smaller spaces might bring up for us. Yeah.
Thanks, Candace. So, real quickly, what do we think the pollutants are in any home that we have to keep track of? What are the things that we need to monitor or control in order to keep the indoor air quality good for the occupants? Okay, thermal comfort could be part of the broader idea of indoor air quality, but I'm looking specifically for things that are considered pollutants. Okay, off-gassing volatile organic compounds that come off of building materials, that's an important one. Others? Humidity. Formaldehyde, interestingly, formaldehyde is technically not a VOC because its molecular weight is too small. It's considered a semi-volatile organic compound. That's what we want to keep track of. I'll give you a couple of hints here. What else do we want to keep track of? Radon. Radon's an interesting one. In a tiny house, do you have to keep track of radon? If it's ground coupled, yes. If it's on piers or a trailer, no.
Mold.
Okay, so mold, but what's the pollutant that is part of the mold?
Bacteria. Moisture.
Moisture. Excellent. That's what I was driving for. So the other ones we have are carbon monoxide, carbon dioxide, right? So carbon monoxide is clearly a pollutant, but carbon dioxide is something that we breathe out, and it's really dependent on the concentration, as it is for water, right? So we have two pollutants that are really closely linked to occupant activities, breathing, right, that move from background substances to pollutants when their concentrations are high enough. So the interesting thing to me about a tiny house is that the volume is very, very, very small. So if we have a trailer or we have a tiny home that's 8 feet wide and 23 feet long and 8 feet tall, that's about 1,400 cubic feet, right? It's a very small volume. So I want you to look at these amounts of water up here and tell me which one you think represents how much moisture is added by one person breathing in a tiny home while they sleep for 8 hours. Okay? Who the hell knows, right? I mean, how in the world would you have any idea how much moisture is, right? It turns out that it's actually a pretty difficult question because as you respirate, you are increasing the relative humidity of the space, and if you bring the relative humidity up high enough, less of the moisture that you breathe out is part of the exchange, right? So it's a moving target. It's actually a very difficult question to answer, but the answer is about 0.8 pounds or 277 milliliters, or about 9.4 fluid ounces. Who cares? Right? Okay, so that's the amount. The question is, I had no idea I was that funny. The question is, if you start at 30% relative humidity at 68 degrees, and you don't bring any new air into the building, and you keep it closed up for 8 hours, what does it do to the relative humidity to add 277 milliliters? So does it go from 30% to 40%? Or 40% to 50%? What would you end up with in interior relative humidity if you added 277 milliliters in 8 hours? 82%, right? So this amount of water over 8 hours in 1,400 cubic feet, you went from 30% relative humidity, which is what we consider the lower limit for being comfortable in terms of relative humidity, to 82% relative humidity, and now you're in the mold and mildew area, right? Now, what's the temperature and the relative humidity in this space right now? Any guesses? What do you think the temperature is? So somebody said 68 degrees. It's actually right around 70. What do you think the relative humidity is? 45? 60? Who the hell knows, right? Because we're pretty good at sensing air temperature. We are lousy at sensing relative humidity. If it gets below 30%, we're pretty good because we get static electricity and we get dry mucous membranes. If you get above 65%, you start to sweat, even seated. So we know when it's above 65, we know when it's below 30, and everything in between, we're not really that sure about. And even when it gets above 70%, it doesn't affect our health. What it does is, it's now in the zone where we can grow mold, mildew, dust mites thrive. So if you have a tiny house that has surfaces that can't absorb much moisture, right? If you live in a house that was built in the 1880s and it's got plaster walls and it's 20,000 cubic feet, it could absorb all of this in 8 hours, right? Easily. But in a tiny house that has a much smaller volume and that has surfaces that can't absorb, what are you going to need to pull that relative humidity down? Ventilation. Now, if you bring cold, dry air in, you're going to do it with an energy penalty. And if that cold gets anywhere near that humidity, it's going to condense, all right? So we have to be very, very careful about how much we bring in and how we bring it into a building. So the physics of a tiny building aren't any different than the physics of a big building, but the volumes that you're dealing with, and if you add a partner or a dog, or if you add a propane cooking stove, which one of these do you think represents how much moisture is given off by burning 1 gallon of propane? Same amount. You burn 1 gallon of propane and it's about 0.8 pounds or 300 milliliters, exactly the same as it was for a person respirating for 8 hours. So it's not that we can't figure out how to deal with these, it's just that tiny buildings make it much more challenging to keep the relative humidity in the right zone away from dust mites, mold, and mildew growth.
Awesome. So that's a little scary, right? So I guess now I want to go back to Anderson and ask, when you build tiny homes, how do you accommodate for that? And what kind of material choices or HVAC system choices help mitigate these kind of problems?
Yeah, so tiny house, whoop, is this not on? I'll use that. Yeah, so humidity, mold, all that kind of stuff. Condensation is a huge issue for tiny houses. We're actually working with a couple who lives in an 8x16 tiny house. They have a vented propane heater, but they have an unvented cooktop. And they're wiping down the walls in the winter. There's so much water vapor. And you know there's going to be mold in the walls. There's probably mold in the plywood. They don't even probably know what they're breathing in. They have no bathroom fan. They're showering without any sort of ventilation. So it's really, really important. It's also a really unpleasant fact that modern materials are awful at water retention. If you talk to old school builders, they're probably used to building without plywood. They might be used to using wood, which can hold water a lot more. But we now build with glue and sawdust in the form of OSB, other man-made joists, or plywood, and those soak up a ton of water and can lead to rot and degradation really, really easily. So yeah, some ways to do that is obviously good ventilation, cooktop ventilation, hood vents, bathroom fans, and there's also something called an energy or heat recovery ventilators. You call them ERVs or HRVs. What these nifty units do is they exchange the humid, stale air trapped in your tiny home, or any home, with fresh outside air, and it uses a ceramic core that prevents the heat loss. So it controls the humidity, it brings in fresh air, and for a space like a tiny house, it is almost essential. It's also something you can add in after the fact, so if you're in the planning stages or already built a tiny house or a regular size house, you can always add them, and they are a really good idea. Also, one thing I do want to talk about are combustion appliances. I think a lot of people, we're also going to want to talk about air quality, and that propane appliances do water vapor, which is a big one, which Peter talked, but they can also give off carbon monoxide, and if they're not installed properly, they can get carbon monoxide. So other ways you could go about it is do an all-electric tiny house like ours over there, which is called the Nova. It's the gray tiny house. You'll see the tiny house crafters sign. So that's all electric. So there's no dangerous propane lines, there's no off-gassing, there's no extra water vapor. And we're also huge fans of spray foam insulation. Spray foam acts as a vapor barrier, so you don't need to do any special venting like you would with Roxol or fiberglass. Yeah, so those are kind of the main points you should think about.
Awesome. So I'm going to try to kind of sum up some of the things I heard today, and then we're going to open it up for questions. So we've left, tons of time for questions. I think we've got about 20 more minutes. So while I'm kind of wrapping up some final points, make sure you jot down your questions on the note cards and hand them back to Alex, because we'll be going through them that way. So some of the things I heard today were that building healthy spaces is kind of about also keeping you sane during the building process. And one way to do that is to manage your costs, ask the really important questions before you even go into the project. So Mel talked a lot about itemizing those costs and asking questions like, is what your tiny house is meant to do, whether it's meant to be long-term, and trying to maybe test it out, whether it's going to be mobile. Let's see, Anderson also talked about thinking about recycled materials, and recycled materials might lower your costs, but then you also have to think about storage and all the time it takes to find those recycled and reused materials. So I hadn't really thought about that either. So then we also moved on to kind of some other issues that might arise in tiny homes. So Peter talked about the kinds of pollutants, and my little list of them were SVOCs, VOCs, radon, and mold and moisture, carbon monoxide, and carbon dioxide. So we also talked about how those might be mitigated, and that there are certain systems that allow you to avoid moisture issues and avoid mold issues. Some of those were the cooktop ventilation systems, including bathroom exhausts, using ERVs and HRVs, and then also thinking about the type of power you're going to be using in your home, whether you're going to have propane cookers or things like that, and maybe thinking about all electric in terms of avoiding indoor air pollutants. So that's my quick little recap. You guys might have had some different points that you pulled out of that. So I'm going to move to the one question that we've gotten so far. Hopefully you guys have been thinking of some more.
Hey, Alex, bring him up. Okay.
Will air exchanger solutions or systems protect from propane gases in a tightly insulated tiny house? And this is from Rick.
Yes, most definitely. The heat exchangers, they bring in fresh air. And most propane appliances, we're not talking about enough carbon monoxide to kill you per se, but a lot of people might have respiratory problems, might wake up a little dry, but yes, they definitely will. Or do you want to add to that?
So the key thing about bringing in fresh air to replace the air that you remove is that if you just have an exhaust fan, then if it's pulling out 50 cubic feet per minute, then 50 cubic feet per minute is coming in, right? The problem is that 50 cubic feet per minute coming in, it's coming from random places. And if that air, which is cold, comes in and hits warm, moist air, then you're going to get condensation. You have no idea where, right? So when Anderson talks about heat exchange ventilation, you're bringing in the right amount through a dedicated pathway, and then when the warm air hits the cold air, it's condensing inside the equipment and being removed. And that's critical, because you do not want condensation to happen on the surface of walls, or even worse, on the interior of walls, where you have no idea it's occurring. The key thing is that the ventilation rate in a space as small as 1,400 cubic feet is really critical. So, in my opinion, you need an expert like Anderson to help you with how these homes work in a bit more complicated way, because their volumes are so small. You're going to need a heat recovery ventilator or an energy recovery ventilator that runs just the right amount or is sized for a building that small. Because if you're over-ventilating the building, it's going to drop too low in humidity, or it's going to be too expensive to heat because the heat's being exhausted with the moisture. One more thing. Carbon dioxide is also a byproduct. We don't know much about human health with carbon dioxide above 900 parts per million. We don't know. We know cognitive ability goes down above 900 parts per million carbon dioxide, but maybe you sleep better, right? Because you're not thinking as hard. There's new research on this, but we don't have the answers yet about exactly what the health impacts are above 900 parts per million carbon dioxide.
Great. So this is a question that I'm not even sure about the answer to. Would you talk about the risks and benefits of using small wood-burning stoves and heating units in tiny homes?
For such a small space, I would not recommend wood stoves. You're either going to be doing sticks 24/7, or you're going to put in a log and open all the windows. We use spray foam. We get about R24, and you could use a 1,000-watt space heater, and it wouldn't even be running full time. So, and also, if you have a wood stove, if that's your primary heating source, you can't leave during the winter, and you're going to lose floor space, which is so precious because you need all the clearances. So I love wood stoves. I heat my house with a wood stove. I'm all about wood stoves, but not in such a small space. It's really not worth it.
Great. So I've had a couple questions about installations, and some of them are related, but maybe we can kind of just open up this as a bigger conversation. So one of the questions is about using sheep's wool for insulation and whether that has benefits of absorbing moisture or not. Its R value goes up, but as it gets damp, does this hurt the performance? And then another conversation about using spray foam insulation and the challenges around temperature gaps, finding qualified people, and I'm going to add human health impacts to some of the chemical constituents that are in spray foam insulation. Anyone want to take it first? Peter, maybe? No?
So there's a whole wide range of insulations that you can choose, from sheep's wool, which is a natural material, all the way to petroleum-based products like spray foam. All materials have what's called a hygrate capacity, and it means what they can safely store before it affects their performance. So, yeah, it's true that sheep's wool can hold a lot of moisture, but its R value goes down quite a bit when it gets wet, because the air spaces are what provide the insulating value, and if you fill those air spaces with water molecules, the R value goes way down. The other thing is that the spray foam is attractive because it forms an air barrier, right? So sheep's wool, air will move readily right through it. The only way the sheep's wool provides insulation is if you put it in a cavity where the air can't move around as readily. So in a northern climate, fully 25 to 40% of the total heat loss of the building is air leakage, right? Either through the walls, through the roof, through the floor, or with doors opening and closing, windows opening and closing. So you need to have both thermal insulation, which blocks conductive heat loss, but you also need to make sure that your walls, your ceiling, and your floor are airtight as well. And the difficult thing for me about this is You've just told me that I need to keep my building really airtight to keep it from losing heat. And then you started by talking about how you need air exchange to protect the health of the occupants. So those are counterintuitive, right? We have to make the house tight enough so that we can then introduce ventilation. The problem with not purposefully introducing ventilation is you don't know how much, from where, and over what time period. So the difference between air just leaking through a space is that you have no control over that air exchange. And in high performance buildings, and I consider tiny homes definitely high performance, you need to have control of that air movement.
I'll just add a little opinion here. I think one of the things that's challenging about tiny houses on trailers is that you're very limited in the dimensions of the building. And so spray foam seems to be a common method for insulating because you get a higher R value per inch of spray foam, and you're trying to maximize the amount of space you have inside. You know, in our work, we're definitely proponents of using more natural products, using materials that have a lower carbon footprint or lower global warming potential. I think just as to put it out there as a challenge to the spray foam industry and to using spray foam is, you know, building a tiny house on a trailer sort of locks you into this product. And you know, if you're looking to build an affordable home and you're not necessarily concerned with it being mobile, considering building a tiny or a small home on a foundation where you have a little more flexibility with materials. You can do dense packed cellulose or rock wool or other products, and you address the air sealing in a different way. So I guess I just want to throw out that little challenge.
The other thing, Anderson and I were talking about this before we started. Spray foam is the only product that you're going to manufacture on the job site, right? So the training and the skill of the installer is critical. You're taking very complex two-part chemicals and you're mixing them on the job site to create the spray foam. So there are certification systems for spray foam companies and for the installers. Never, never hire a spray foam company or installer that has not been third-party certified by one of two organizations in the United States, because it's really hard to get spray foam right, and if you get it wrong, it won't do its work, and it certainly can have health impacts.
Are there two organizations? You said two organizations.
Sorry, the two organizations are the Air Barrier Association of America, that's ABAA, and the Spray Foam Products Association, that's the SFPA. Both of them have third-party certification for companies and installers. So ABAA and SFPA.
So Mel, you suggested trying out a tiny house living before taking the jump. Do you have any suggestions for where you can go to do that?
I do if you don't.
Yeah, well, I guess just to kind of add a little more to that comment, I think there's an interesting conversation happening in part as a result of this festival happening here, but certainly as a result of the tiny house movement and the increased popularity. And I won't open a can of worms in talking about affordable housing, but I do think it's an interesting thought as to what motivates folks to build a tiny house and whether or not it's by necessity or by choice. And I think, you know, one of the things and I mentioned this earlier, but just considering, you know, are tiny houses viable for families, for people with small children and pets? You know, I'm sure that there are stories out there of folks who are making that work. And I think one of the things that really appeals to folks is that in order to live in a tiny house, you have to completely downsize, right? Unless you have a storage facility somewhere else, you're getting rid of the majority of your stuff. which is a cool idea. We all have probably too much stuff. But yeah, I mean, I think, and Anderson probably has specific examples, but there are like B&B, Airbnb, tiny houses that you can stay in. I think that some of the readings I've done about it, folks will go and they'll spend a weekend in a tiny house, and it's cute, and you're in the woods, and it's nice, and it's fun for a weekend. And you know, if there's a way you can go and live in one for a month at least, you know, rent one out. And again, is it in an urban setting? Is it deep in the woods? Is it in a co-housing with a bunch of other tiny houses? These things really matter as far as the sustainability of that lifestyle.
Yeah, there's actually a tiny house Airbnb website that I think people should go onto if you want to check it out.
What?
There's a tiny house Airbnb website, so it's just a special for living in or renting out tiny houses.
Great.
Yeah, I've actually tried that before. There's one called The Getaway that's centered around Boston, and it's super nice. Okay, great. So we had a couple questions actually about how plants impact indoor air quality. So one was about how much they actually add moisture, but another is about how they might offset carbon dioxide in a small space.
So I wrote a blog called Household Sources of Moisture, and if you go to greenbuildingadvisor.com, it's a blog that's free to access. And in that blog, I talk about the impact of moisture, but also generation rates for various sources. And I'm going to guess here, 6 to 8 plants generates about 2 pints a day. And that sounds like a very small amount, but in a tiny house it's significant. Now, of course, it depends on what type of plant. If it's a bonsai versus a palm frond, you know, that's going to make a difference. But I suggest you go to that blog. One of the interesting things is that how many pints of water do you think a quart of wood gives off in one heating season? 400 to 600 pints of water comes out of 1 quart of wood. So I don't care what kind of house you have, be really careful about how much wood you store inside your house, because it cures inside your house, and that means that all the moisture that's leaving that is headed into your walls. But plants are not a significant contribution to moisture in regular homes, but they could be in tiny homes.
Okay, so a few questions I just wanted to mention. We might not have time to get to them today, but there are other sessions today that will cover them. So there are a few questions about zoning regulations and a few about some the solar options. So I'm going to put those off because other panels will be addressing those today. Maybe we can go to talking about electric radiant floor heating and what the options are for tiny homes.
Yeah, there's a ton out there. That's actually a really good option. I'd recommend it, as long as you can get the appropriate electric hookup for it. But yeah, that would be a really, really good way to go. You could also do water radiant heating with an instant on-demand propane water heater. If you do go the electric heating route, which I wish I mentioned earlier, I would recommend a generator, some sort of backup, because when the power goes out, that would be a bummer for all the above.
You guys want to talk about that now?
Just one quick thing about floor radiant heating systems is that they're relatively slow to react, right? Because they heat the materials that are part of the floor assembly. Might not be as much of a consideration in a tiny home because the space is so small, but if you want to very quickly bring the temperature up or down in any building, mass systems like floor systems react pretty slowly. The thermal comfort they provide is hard to rival, but if you're trying to do setback, that would be setback, and rapid rise, you need something that's a bit more quick than a floor system.
Great. So there were a few more questions that think about ERVs that I handed you, Anderson. Yeah.
So there's a question of saying what air exchangers are available for tiny houses, and are they available for 12 volt? And the other question is, if you have a HRV and you want to keep your windows open in mild weather, what would be the considerations for that. The first one I can touch upon, that ERVs are a relatively new thing, and most ones that are out there for full-size houses. There are a couple units that are coming online that are for bedrooms or tiny house. So we use one that's called Twin Fresh, I think is the brand. And if you want to come to my booth, I can talk to you about that today. It is not 12 volt, so you probably need to get an inverter, but that is definitely possible. And it's a really small, it's a 6-inch fan pretty much. It just goes right through the wall. It looks really good. It looks no different than a bath fan. In terms of windows open, I'm not entirely sure. I don't know if Mel or Peter, you guys want to talk about that? Talk about windows open in an ERV?
So the key for an ERV and HRV is that it brings in as many cubic feet per minute as leaves, so the building doesn't pressurize or depressurize. Having the window open is not going to change that unless the wind's blowing. So if you're spending a lot of money for an energy recovery ventilator, probably not a good idea to open the windows because you're just letting dollars flow through there.
Would you recommend turning it off when the windows are open?
Yeah, so Anderson was saying, would it be better to turn it off? Yeah, fresh air through a open window or door is definitely the right way to go. Yeah, it would make sense to turn it off for that time period.
I was just going to add, if you go to 475.com, they sell a very small HRV that's ductless. It's called the Lunos. And they're just coming out with a new model that's for even smaller spaces. So I know other tiny house builders who have put those in. They're expensive. They're going to be between $1,000 to $1,500 just for the 2 units. But they're pretty easy to install, so it could be something that you could do yourself.
Great. So I did not get to all the questions, but we're going to be leaving our business cards up here. Some of us have to leave right after, but we'll leave our business cards, and you guys can ask the remaining questions after time. I'm going to finish this up here with one last question, and each of you can respond if you will. This sounds complex. How do I know if I'm designing or building it right?
Wow. Well, if you're doing it all on your own and you're designing from scratch, do you want to? Designing from scratch, that's tough. It's tough to really know. I mean, you're probably going to need to want to get an expert. There are a lot of moving parts, especially if you're taking on the project from yourself. You're trying to become a roofer, a framer, a window installer, a plumber, electric roofer. So if you're doing it yourself from scratch, you probably aren't going to get everything right. And if you want to get everything right, you're going to probably have to hire a professional. And if you hire a professional, it's going to cost some money. So I think that's a moving target. And I think the definition of what right is also a little bit of a moving target. Do you really mind if it's a little wonky? I think the things we were talking today about condensation, mold are more focused on human health and are really important. I would recommend really doing your research or talking to a professional. But some of the things right is a little weird, but I think for our discussion, you'd really want to dig into that.
Mm-hmm. This was the part I cut from my talk, so thank you. So with a typical house, it's usually recommended to hire an architect or a design builder or a knowledgeable builder to help you create the construction documents. And really I see 3 reasons why you want to invest in the design phase. One is it gives your builder or yourself a roadmap for what the process is going to be, what the specifications are. And, as a project manager, an efficient process is going to save you time and money. Second is that with a good set of plans and a detailed estimate, whether it's your builder doing it or yourself, you know what you're getting yourself into financially before it's too late. I work with a lot of owners, and homeowners and business owners who have sort of a DIY mindset, but aren't necessarily experts in all these fields, and they get halfway through the project and sometimes run out of money, or they're ready to start a project and then the pricing comes back and they realize it's way beyond their means. And so I guess I would encourage, even if you buy plans online, engage, whether it's an architect or a consultant or a builder, or preferably someone who understands building science, someone who has some familiarity with the particularities of tiny house, because it is serious stuff. You don't want to throw down 25,000 and then have it rot from the inside. And so if you are really motivated as a DIY person and you're like, I want to do this, this is really fun and exciting, a few resources. Green Building Advisor is a great place to go. And there's part of it that's free, part of it that's a membership, but you can go online and you can Google different topics and read experts, and then almost more importantly, read the commentary of various geeky building scientists talking about those issues. Building Science Corporation is another one. And then the other thing is there are a lot of programs out there doing tiny house workshops. So Yes Tomorrow is a local one. There's a Hammerstone Carpentry for Women over in Ithaca, and there's probably a ton others. Go and take a class and work on a tiny house and see how it feels, and whether or not. Yeah, you good?
Good, all right.
Thank you. That finishes it up. Thank you.
If you have any more questions, I'll be at our booth. Tiny House Crafters will be wearing the green shirts. Thank you.